Reaction of ammonia with ethyl chloride. This is an example for ammonolysis reaction. The alkyl halide taken is ethyl chloride. It is made to react with ammonia NH3. So initially we get the primary amine C2H5NH2 which is ethanamine. The primary amine ethanamine thus obtained reacts with more of ethyl chloride to give a secondary amine. The secondary amine formed is C2H5NH2H5 and the name of the compound is N-ethyl ethanamine. The secondary amine in turn reacts with alkyl halide that is ethyl chloride to give tertiary amine. The tertiary amine obtained is N-diethyl ethanamine. The tertiary amine thus obtained can again react with ethyl chloride to give quaternary ammonium salt. The formula is C2H5 4 times N plus Cl minus. Let us now consider another ammonolysis reaction. Ammonolysis of benzyl chloride and the reaction of the amine so formed with 2 moles of methyl chloride. So initially we have to start with benzyl chloride. The formula of benzyl chloride is C6H5CH2Cl. This compound undergoes ammonolysis reaction. So it should react with ammonia NH3. So you get the product C6H5CH2NH2. This is benzyl amine C6H5CH2NH2. The reaction of the amine so formed with 2 moles of methyl chloride. So benzyl amine should then react with methyl chloride. You get C6H5CH2NHCH3. This compound formed is then made to react with 1 more mole of CH3Cl, methyl chloride. Then you get the final product as C6H5CH2NCH3CH3. And what is the name of the final product? It is NN-dimethyl phenylmethanamine. NN-dimethyl phenylmethanamine. Amines can also be prepared by the reduction of nitriles RCN and amides RCONH2. To carry out reduction, we have to use a reducing agent. Which are the different reducing agents used here? Hydrogen in the presence of nickel, sodium amalgam and ethanol, lithium aluminium hydride followed by reaction with water. So if we start with a nitrile RCN, the reduction gives the amine RCH2NH2. Similarly, when we start with an amide RCONH2, the reduction gives the amine RCH2NH2. For example, consider these equations. If the nitrile taken is ethane nitrile CH3CN, the compound is named as ethane nitrile because 2 carbon atoms are present and the functional group is CN. So it is ethane nitrile. When a reduction is carried out using hydrogen and nickel, we get the compound CH3CH2NH2. Note that the CN group changes to CH2NH2. Thus we get the amine ethanamine. Now consider the next example. If we start with propane nitrile, if we carry out reduction using sodium and ethanol, ETOH means C2H5OH which is ethanol, we get propanamine. And if we start with an amide, say for example ethanamide CH3CONH2, the reduction is carried out using lithium aluminium hydride followed by reaction with water. This gives the amine ethanamine. Note that the CO group changes to CH2. Next method of preparation is Gabriel's phthalimide synthesis. This method is used for the preparation of primary aliphatic amines. Note that this method cannot be used for the preparation of aromatic amines. Now what is this method? Here, phthalimide is made to react with potassium hydroxide solution. It forms potassium salt of phthalimide. Potassium salt of phthalimide is then heated with alkyl halide RX. So you get the compound N-alkyl phthalimide. This is then hydrolyzed using aqueous sodium hydroxide, which gives a primary amine RNH2 and the sodium salt of phthalic acid is also formed. Let us see how to write the equation showing the formation of primary amine, aliphatic amine, methanamine, CH3NH2 using Gabriel's phthalimide synthesis. So start with phthalimide. It is made to react with potassium hydroxide solution. You get potassium salt of phthalimide. This is then made to react with which alkyl halide? If we have to get methanamine, take the alkyl halide as methyl chloride. So when it reacts with methyl chloride, we get N-methyl phthalimide. N-methyl phthalimide upon hydrolysis using aqueous sodium hydroxide gives methanamine, the product. Along with that, we get sodium salt of phthalic acid as byproduct. Gabriel's phthalimide synthesis cannot be used for the preparation of primary aromatic amines. It is because the aryl halide cannot undergo nucleophilic substitution reaction with the anion formed by phthalimide. You know that if we get the potassium salt of phthalimide, when it is treated with Rx, we get N-alkyl phthalimide. So such a product cannot be obtained if we take an aryl halide. The aryl halide will not undergo nucleophilic substitution with the anion formed by phthalimide.